Okay, let's look at Boolean logic in Java. Boolean logic is named for this fellow, George Boole. He was an English mathematician and philosopher. He lived in the 1800s. He, as the inventor of Boolean logic, which serves as the basis of modern digital computer logic, is considered one of the founders of the field of computer science. Now, Boolean logic uses logical operators, the and, the or, and the not. We have both an inclusive and an exclusive or. So our logical operators are the and, the or, and the not. When we're looking at Boolean logic, we are looking at conditions. And a condition is a test, something that evaluates to true or to false. Our first operator is the and it looks at the intersection of two conditions. Both must be true to return true. So if I have two conditions and both are true, I return true. If one or the other or both is false, I return false. The symbol for and in Java is the double ampersand, and the ampersand is found on your keyboard above the number 7. And here I write a test that uses the and operator. And I test to see if both condition 1 and condition 2 are true. If both condition 1 and condition 2 are true, I return true. If not, I'll return false. That is, if either condition 1 or condition 2 or both condition 1 and condition 2 are false, I will return false. The second operator is the or, and here I have the inclusive or. It looks at the union, and the inclusive or tests my two conditions. If one or the other or both of my conditions are true, I return true. If both of my conditions are false, I return false. So I return true if and only if one or the other or both of my conditions are true. This is the inclusive or. And the symbol for the inclusive or in Java is the double pipe or the pipe. You'll find that above the backslash on your keyboard. And here I test condition 1 and condition 2. I am testing if one or the other or both of these conditions are true, I will return true. If both of these conditions are false, I will return false. There's also the exclusive or. It too looks at the union, but the test here is looking at the two conditions. If one or the other but not both of those conditions evaluate to true, I will return true. This is the exclusive or. One or the other but not both. So if both of my conditions are true, I return false. If both of my conditions are false, I return false. If one of my conditions is true and the other false, I return true. So one or the other, but not both. This is the exclusive or. The symbol for the exclusive or is the caret, and that's above the number 6 on your keyboard. And here I test condition 1, condition 2. If one or the other of those two conditions, but not both, is true, I'll return true. The third is not. The third of our operands is not, and it's the inverse. It flips the value. If something is true, it becomes false. If something false, becomes true. The not in Java is symbolized by the exclamation point, sometimes called the bang. And I simply put that exclamation point in front of my condition, and it reverses that condition. If my condition is false, it becomes true. If it's true, it becomes false. Now, when we talk about the evaluation done under Boolean logic, we have both short circuit or lazy evaluation and complete. Short circuit evaluation is symbolized by the double ampersand and the double or, the symbols that we've used thus far. Complete evaluation is a single ampersand or single pipe, and we'll talk about that. Complete versus short circuit evaluation. If we are doing an and, seeing if both conditions are true. Under lazy or short circuit evaluation, as I test condition 1 and condition 2, if condition 1 is false, I'll stop. because I've already got the answer. If condition 1 is false, I know that my AND must evaluate to false. So I'll stop right there, because remember, under an AND, both conditions must be true. Under full evaluation, and on full evaluation I use the single ampersand, I test both conditions, even if condition 1 comes back false, and I therefore know it's going to evaluate to false in total. I'll still test both conditions. This is complete versus short circuit evaluation, or lazy evaluation, for the AND. In the OR, I can do complete or short circuit evaluation for the inclusive OR. Under lazy or short circuit evaluation, I'm looking at condition 1, condition 2. If condition 1 is true, I'll stop. Because if condition 1 is true, I know under the inclusive OR, it's going to evaluate in total to true. Because remember, the inclusive OR is one or the other or both. Under full evaluation, I'm looking at condition 1 or condition 2. I'm going to test both conditions. Because I, under full evaluation, don't care if I know the answer already. I'm going to test the whole way through. Now, the exclusive OR, I can't use short circuit evaluation, because remember, the exclusive OR looks at one or the other but not both. So if condition 1 is true, I have to continue, because I have to see if condition 2 is true, because if it is, I'm going to evaluate to false. If condition 1 is false, I'm still going to continue, because I have to evaluate condition 2 to see if it's true. So with exclusive OR, symbolized by that caret, I cannot do lazy or short circuit evaluation. I have to do full evaluation. So here's what we've looked at thus far: the AND, the OR, and the NOT. Remember, the AND is both conditions must be true to evaluate to true. The OR inclusive, one or the other or both. If one or the other or both of the conditions is true, I return true, otherwise I return false. On the exclusive OR, one or the other but not both. If one or the other but not both of the conditions are true, I evaluate to true, otherwise I return false. And the NOT simply flips something from being false to true, true to false.